Section 4.1, lecture for the homework. So here we are defining first some definition, like what is event, collection of result, or outcome of procedure. Example, the single birth is an event. We have a simple event, it's an outcome or event that can be further broken into simpler component. So when you flip a coin or rolling a dice or single birth, these are all simple events. Sample space is all the possible simple events. For instance, when you flip a coin, you either get tail or head. So these are sample space, all the possible outcomes. Or when rolling a dice, you get one of the 6 numbers. A baby is born, so it's either boy or girl. There are 3 definitions here. One is they call it relative frequency approximation of probability. When you conduct a procedure and count the number of times that event actually occurs, as the total number of observations increase, corresponding approximation tend to get closer to that. So to understand this one, this kind of relative frequency, this is a good example based on the experience. Like here, find the probability that NBA basketball player Reggie Miller make a free throw after being fouled. At one point in his career, he made 5,915 free throws in 6,679. So it shows based on the past experience, what's the chance of him making a free throw. So in that case, we take and divide these 2 numbers. So that would be 0.886. The second one is the classical probability. Assume the given procedure has n different simple events, and each of this has equal chance of occurring. A good example is rolling a die. So all 6 numbers have the same chance. All 6 numbers, 1, 2, 3, 4, 5, 6, they all have the equal chance of occurring. So this is an example of classical probability. So what's the probability of when you roll a die, number 2 appears? 1 out of 6. What's the probability of number 5? 1 over 6. They all have the same probability. He said, do not assume that the outcome is always equally likely. For example, we could not conclude that probability of passing a test is 50%. No, it's not. The actual probability depends on factors such as amount of preparation and difficulty of the test. And then the last one is subjective probability. Probability of event is estimated by using knowledge of relevant circumstances. For instance, when trying to estimate probability of rain tomorrow, it just depends where you live. When trying to estimate probability of astronauts surviving a mission in the space shuttle, experts consider past events along with changes in technology and conditions. As of today, probability is 99%. Like, what's the probability of rain tomorrow? It just depends where you live, what part of country do you live. A couple have 3 children. What's the probability of having exactly 2 boys? These are all the possibilities for 3 children. And then you look to see which one has exactly 2 boys. The exactly 2 boys is here, 1, 2, 3. Out of these 8 outcome, 3 of them has exactly 2 boys. So 3 out of 8. That's the probability of having exactly 2. And these are some other examples of relative frequency, classical and subjective, that you can study. Now, one of the formula that we use often in a stat is complement of 2 variables. For instance, here, probability of A plus probability of A bar. A bar is the complement of that. For instance, there are 20 male and 40 females, right? So altogether, there are 60 of them. What's the probability of a male? Probability of male is 20 out of 60. In that case, if you want to calculate probability of female, there are 40 out of 60 female. You could either do it this way, or what you could do, you could take this number, which is like a PA, and subtract from one to find the other one, so you don't have to do these calculations. For instance, if the probability of male is 1/3, how do I calculate probability of female? 1 minus that based on this formula. There are 5 red marbles and 10 yellow ones in one basket. When you pull one, if you randomly select one or pull one marble out of the basket, what's the probability of that marble is a red color? 5 out of how many marbles we have all together? So if you notice, denominator is always the total numbers. What's the probability of, if when you're pulling a number is red, 5 out of 15? What's the probability of yellow? So you either just say 10 out of 15, or you could just subtract it from 1 based on this formula. Remember, probability is always between 0 or 100%. The reason is this. What's the probability that Thanksgiving is on Thursday? 100%. See, probability is 100% or 1. What's the probability of Thanksgiving is on Wednesday? 0% or 0. So probability cannot be negative and cannot be greater than 1. Why? Because 100% is the maximum. We don't have 120% or 130%. So probability is always between 1 and 0, and it's positive. It cannot be negative. Guessing on SAT test, there is one question with 5 choices. What's the probability of 4 answers are not correct? Probability of incorrect is 4 out of 5. What's the probability of correct one? 1 out of 5. And these are the formula of addition rule and complementary event that we talk about. And this is, in the next section, we'll talk about this one more often. Now let's look at the examples here. For the first one, we are using the formula. If you have the P of A, how do you calculate P of A prime? Sum is 1. You just subtract this from 1. Or here, they're asking you whether increasing website indicate 15% chance. When it's 15% chance, that means there is a 15% probability that it will rain somewhere in the region at some point during the day. Now, remember, the probability has to be positive. It cannot be 1. It cannot be negative. So when you have a bunch of stuff like that, you go through it and you pick the correct one. Okay, and then we go to number 4. I have the solution for all this here. And most of this is kind of very obvious, like 8 of 100 digital record. What is the probability of randomly selected item is defective? It said here that the probability is 8 out of 100, because 8 of the 100 is effective. So when 8 out of 100 is no good, when you randomly select one, what's the probability of the video that you're pulling out is defective? 8 out of 100. And then this one, there is 1,100 birds and 1,054 are girls. So what's the, when you want to decide to have a person randomly select a person, what's the probability of that person be a girl? Is 1,054 divided by 1,100 is 0.958. You could always move the decimal 2 points. 95.8 is significantly high. It's a very high number. It's almost close to 100. And then on this example, in 1,100, 554 are girls. So probably 554 divided by 1,100 is 50%. So 50% is in the middle, neither significantly low nor significantly high. Here is number 7. We have, for a certain lottery game, the odd in favor of is 23 to 77. 23 to 77 is 0.23. And then we go to number 8. In a certain instant lottery, the chance of winning is 2 to 23. When you say 2 in 23 means ratio of 2 over 23, which when you find a decimal, and they ask you to round it to decimal places, so it would be just 3 digits after the decimal. And they all are, you could actually see the solution for all these is number 9, the chance 13%, number 10, and we understand that probably always have to be between 0 or 1. When using the computer to randomly generate last digit for the phone, there is 1 chance in 10. The last digit is 0. The probability is always between 0 to 1. So what is the probability of 0? 1 over 10. So here, again, when we say probability is 50-50, 50-50 means that. 50-50 chance, it means 50%. Number 12, you're certain the number of face card. When selecting, express the degree of the likelihood. What is the probability? The set of the deck of the card has numbers and face, so nothing else. So when you pull one out, what's the probability of when you draw a card is number or pictures? 100%, because those are the only items that you have on the card. You either have the pictures or you have numbers, so it's 100%. It is impossible to get 6 jack when selecting a card, of course, because deck of the card has only 4 jacks, so you cannot pull 6. So probability of 6 jack is 0. Why? Because there is only 4 jack in deck of the cards. Now, problem like these, you have a bunch of problems like these. On this type of problems, before you actually go to the question, what you need to do is first, you need to add all the numbers on each row and on each column. When you do that, you find the total number here. You want to make sure that when you add these two and these two numbers, they both match. They both are 86. So on each row, I add these two numbers, 56. This 2 is 30. I add numbers in this column and that column. In either direction, you have to come with 86. Now, question is this. What's the probability of a false positive? In the case like that, the test shows positive, but the person actually did not use the drug. So you need to find the intersection. How do I find the intersections? You go from the top and this is a number. These are the number of people that the test was positive, but they never used the drug. So it would be 2 out of 86. Again, the denominator must always be the total numbers. So you need to have the correct number here when you do. So probability is 2 over 38. The same thing for these problems. You have, what you do is you just add these two numbers, you add those, you add these columns. So 37 plus 55 is 92. You also add these two, 51 and 41, to make sure that is also 92. When in either direction you come up with the same number, then you know your table is correct. You could continue with the problem. Now here they're saying, what is the probability of subject not lying? How many people did not lie? Did not lie, 10 here, 27, 37. 37 out of what? Remember, the denominator is always a total number. 37, 92. That would be 0.402. So they're saying, is the result close to 446? You see these two numbers and you compare? Yes, it's very, very close. This two. On number 16, result 281 baby and 5 baby boys. There are 281 baby girls and 5 baby boys. What is the probability of the girl? Again, probability of a baby is born is a girl is there are 281 girl divided by the total number. That would be 98.3% is chance of having a baby here. So that means the technique is really working. It's very effective. On this one, there are offspring samples, 444 green and 161 yellow. So altogether there are, this is the total number. What's the probability of when you pull one out is the green? How many green did you have? 444. So 444 divided by total give you a probability of when you randomly select one is the green ones. Is that probability close to 3/4 or 0.75? Yes, you see that they're very close. On the first day, Kelly asked Mike to guess date of the birth is what? He wants to guess it has to be 1 out of 365. So you see it's probability of correct guess is extremely small for Mike to come up with a correct guess. It is unlikely for Mark to guess correctly on his first try. On number 19, in a survey of consumer 12 and older, residents were asked how many cell phones were they used. So among the response, 202 none, 294 said 1, 370 said 2, and 148 said 3, and 144 response with 4 or more. So what's the total number for all these? You add all those two. What their question is this: what is the probability of having 4 and more? X greater than 4 or more. And then we indicate here that there are 144 with 4 and more. 144 responded with 4 and more. So the probability is 144 divided by total number, which is 0.124. Is it unlikely for a household to have 4 or more? No. Why? Remember, in a statistic, if the probability is greater than 0.05 or 5% is usual. If the probability falls below 5% is unusual. And here the probability is 0.12, or if you move the decimal, it would be 12.4%. So it is a among 450 selected driver 20 to 24, 10 were in a car crash last year. So in that case, out of 450, they had 10. If you randomly select one, what is the probability of a person being in a car crash? 10 out of the total number, 450, which is, if you move the decimal, 2.2. Remember, 2.2 is less than 5%, so it's very, very unusual. Again, if the probability falls below 5%, it's very unusual. 5% is 5 divided by 100 or 0.05. Now here on 21, there are two colors, red and blonde. Blonde and red. What's the possibility of these two colors? The colors can be red and red, red and blonde, the first one red, the second one blonde, the first one blonde, the second red, or both are blonde. So there are 4 possibilities. Questions, what they're asking on B is to find the probability that the child has blonde. What's the probability of a child come with blonde? Is 1 out of 1, just one of them. Out of 4, one of them has this situation, so it's 1 over 4. What's the probability of red in it? These 3, they all have red in it. This one doesn't have red, so it would be 3 out of 4 or 0.75. And here on 22, they want to know what's the probability of exactly 3 boys. So you look here, the only one that's 3 boys is this one, 1 out of 8. Now, this, they call it the tree diagram. Tree diagram is very important in the statistics. Let's say if I want to draw the tree diagram for a couple want to have 2 children. We want to know all the possibility of these 2 babies. If the baby is born is either boy or girl. What's the probability of boy? 50%. And what's the probability of girl is 50%. Now, that's the first baby. Let's say the first baby is boy. The second one could be either be boy or it could be girl. Again, the probability is half and half. If the first one is girl, the second one could be boy or could be girl. Half and half. So what is all the possibility of 2 babies? You go through the branch of the tree. You say it could be either boy, boy, both of them are boys, or the first one is boy, the second one is girl. The first one is a girl, the second one is a boy, or both are girl. These are all the possibility if a couple have 2 babies. And now how do I calculate the probability? Is 1 times 1 is 1/4, 1/4, 1/4, 1/4. The sum of the probability always have to be 1 because each of these is 25%. So the sum always has to be 100% or 1. This is for 2. This is when couple want to have 2. Now, if you want to have 3, then you just expand this. This is in case of 4. So these are all the possibilities of 4 babies. So what is the probability of 4 girls? The only one that has 4 girls is right here. Is 1 out of 16. You see, so how many possibilities do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay? So 1 out of 16 is probability of 4 girls. The only one that has 4 girls is right here. Number 25, a study of the cell phone, the study of the 420,095 cell phone result in 135 who develop cancer. So probability of person getting cancer through the cell phone is 135 divided by that. And you see the number is extremely small, very unusual. So in that case, based on that, then they're asking the probability show that the sample result is, probability show that sample results could have easily occurred by chance. So they're saying when they take a samples, it was 0.51 or 51%. So this is not correct. It could be only by chance because we know based on general study, probability is extremely low that person who's using the cell phone that causes cancer. And the rest is just a multiple choice. The last 2 questions are the multiple choice for section 4.2.